Hey, how's it going, guys? So today we're going to be talking about streams in Java. So I was scrolling through TikTok and I was watching coding videos, and I saw that a lot of people were kind of still unfamiliar of the concept of streams. So probably if you're curious about streams, you're either new to Java development or kind of new to developing in general. Streams have been around in Java since 1.8, so it's been around for a little bit of time, and they're one of probably the most useful things that you can use on a day-to-day basis of developing. So let's go through it a little bit. So first of all, what are streams? As I just said, so streams were introduced in Java 8. Basically, streams are wrappers around a data source. So the data source can be a collection, so it could be your list, or maybe something that you're retrieving from the database through a Spring repository or something like that, an array, or an input-output stream. And these will provide the data to the stream. Streams allow us to process data that may be large in size, conveniently and fast. So streams have a higher upfront cost to set up because there's always this question of efficiency and how performant are streams. Not even considering from a asynchronous or taking into account how effective the lazy programming methods are, or the lazy enhancements are for streams, which we can get into that next. Streams, when you have large amounts of data, will process that faster than just going through with for loops due to various optimizations. Now, there are higher upfront costs to set this up, so you have to take that into account. If you're processing 5 to 10 records of something, maybe it doesn't make sense to throw it into a stream. But now if you're getting into the hundreds, now streams will be more efficient. And maybe even hundreds would be low. But when you're working on enterprise applications or any applications where you're really taking in and working with a bunch of data, you would like to probably go more towards the way of streams. So there are two types of operations on streams. The first of which are terminal operations, and the second of which are intermediate operations. Now, terminal operations mark the end of the stream and return the result. So basically, if a terminal operation is called on a stream, the stream is then ended. So that will be the last thing that gets called on a stream. A lot of the time you'll see things like collects or for eaches or find first, and we'll get into a few the greatest hits of those. But for now, just so you know, when you call a terminal operation on a stream, that will end the stream from being processed, or marks the end of processing the stream. Now, the other side is intermediate operations. So what are intermediate operations? First of all, the intermediate operations are lazily executed, and they return a stream as a result. So now, I touched on lazy before. Now, when we get to how does lazy execution work in streams, there's two portions that we have to understand. First of all, if for any reason intermediate operations are called on a stream without a terminal operation to end it, they are never executed. Intermediate operations on their own will not be executed. They require a terminal operation at the end. And if we dive a little bit deeper into why does that actually happen, it's actually kind of interesting. So each intermediate operation processes for the whole set of data at once. So if you have, let's say, maybe 3 filters in a row, and then let's say a find first, and I'll show you this in the coding as a better example. If you have these 3 filters in a row and then the find first, if let's say that all of those hit on the first object in your data stream, you won't be doing all the rest of the objects. So it's very important that the stream understands, hey, what are we doing with this data at the end? What is our end goal for this? Are we collecting it all to a set? Do we only care about the first one that actually matches this criteria? So it's very important for the pipeline to be properly built out for the stream. So kind of getting into the greatest hits, these are ones that I use on a day-to-day basis. From the terminal side, we have, and just, sorry about that. I have to move myself there so you can see that. From the terminal side, we have collect and for each. Now, collect basically collects the results of all the intermediate operations to a collection. So you may go through and you may want to map a bunch of data to something else, and then come back and collect all that data to a list or a set. So collect gives you that ability to basically kind of package everything when you're done into one final output. For each, goes through everything in the stream, every element of the stream, and performs something. Now, people get caught into kind of this anti-pattern when they're using for eaches, where they'll be like, okay, I'm going to create this list outside of my stream, and I'm going to add everything into it in the for each. So when you're doing that, the code smell that we're seeing there is that we should really be using a collector. I've done PRs in the past, and I've looked through code where people are using this for each to kind of affect a outside object. So the rule with lambdas and the rules with streaming in general is that a stream should not affect anything outside of that stream. So whether it be a list or a collection outside of that stream, we should always kind of make everything confined to within the stream. Now, those are two kind of terminal operations. Now, there's many more. You have find first, you have find any. There's tons of them. But the point of going through this, because we could spend all day talking about every kind of operation, is to get a kind of an understanding of streams, how they work from a higher level, right? So let's jump into the intermediate side. So first of all, we have map. So for maps, as you see here, we have this integer x, and we're doing x plus x here. So maybe this x, while here is an integer, and we're just doing 2x or x plus x, it could be maybe you have an employee, and under an employee, you have their employee location or which building they work in, let's say. You can actually map that to get which building they work on using a method on that employee, let's say. It doesn't need to be specifically like a mathematical equation. It's just what we need to understand here was we're applying some logic to every object in the stream. Now, there's a hard and fast rule with maps that any map of one object must return one object. Now, if you get into something where you need to have multiple objects returned from a map, or maybe no objects, then you're going to start getting into what's called a flat map, which is also very useful, but maybe you can have one employee which returns a list of their students, let's say if they're a teacher, right? So that's kind of getting more into flat mapping. Now, and the next we have here is filter. So a filter basically selects the elements as the predicate that's passed to the argument. So this is the predicate that we're passing in, and we're basically saying for each employee, you filter out any employee that has a salary that's greater than 10. So we want to just keep the employees that salaries are greater than 10. So that gives us kind of an idea of these intermediate operations as well as these terminal operations. And we're going to jump into the code level and talk a little bit more and go over some examples. But before we do that, just to kind of get a good idea as we talk about what is this whole stream pipeline and how does it work. A stream starts off with a data source. It must have the data source, right? So that's where you're creating the stream. You're turning something into a stream. Then you can have 0 to n intermediate operations. You can have multiple filters. You can have multiple maps. Those are not required. You are not required to have an intermediate operation. You may want to stream something, and you may want to do a for each on it, right? You want to jump straight to that terminal operation. That is fine. So this portion here is a non-required or optional portion. Now, what is required is your terminal operation. How are you going to end the stream? Your intermediate operations are all returning streams, but your terminal operations likely will return will not return a stream. They'll return something concrete, whether it's an object, an optional of that object, or a collection. All right, so now that we've kind of wrapped through this and went through the high level, what is a stream and how do they work and how do we need to use them and why would we use them? Let's jump into actual code and go over some code examples of why and how we'll use the stream. All right, so now jumping into the code level, what we have here is the normal Java way, pre-Java 8, of kind of working with these collections. They're just basic for eaches. And I have quite a few methods here that I did build out, and we're going to go through each and every one and convert it into streams. Now, at first, streams are a little bit less legible, I would say. But as you really work with them, I think that the functional aspect and just how streams are created make it a lot more easier to read code. Now that's a subjective part of it, right? So, but the part that isn't subjective is that on the higher amounts of members inside of a stream, let's say, it does become more performant. So let's see. The first one we have here is fetch all computer science teachers. So if we execute fetch all computer science teachers here, we'll see that it goes through and it is looking and pushing out basically a list of all the computer science teachers in. And this is just plain old Java, right? So what we're doing here is we have a for each loop of all the teachers on the teacher list. And for each one, if their subject is computer science, we add them to another list and we turn that list. And let's see how we can do this in a streams way. So I'm going to comment this out. And basically what we'll just do is we will return. So we'll take the teachers list and we'll stream it. So stream is basically what we have on collections to turn it into a stream. If it was an array, you can also use arrays.stream. Or the stream library itself has a stream of. But since we're using a collection and since we're using a list, we can just use this nice little fancy .stream, and that will convert into a stream for us. Now, the next thing we're going to do here is we're going to use filter. So now filter is one of those intermediate operators that we were talking about previously, and that filter is basically going to say, hey, listen, if this passes this criteria, so it's your if check basically, then I'm going to filter that portion out. So what we can do here is we're going to pass a predicate. So we'll create the predicate of teacher, passing in this teacher, right? So this is basically a function inside of the filter method, and you can break this out to a functions to where this filter is just calling a function. That's a nice way to do it, and I feel like that increases legibility. But for now, since it's such a simple little thing, we're going to do it right in line. And we'll just say teacher, that gets subject, that equals, and this is for computer science teachers, so we'll use subject.computer science. And then we will collect that to a list. So kind of going over it, you have your intermediate operation, which is your filtering, and then you're collecting it using collectors to list. And now we can clean this up a little bit. I like to use static imports. And if I rerun it, we should get the same output, right? So we have all of our computer science teachers here: Brianna, Steve, Peter, Michael, Dennis, and those are all here coming from our generate teachers list, which is just some dummy data we have here. So this became this, and I like to make my streams multi-line like that, so that you can kind of see what each one's doing. It also makes them easier to debug. But the next up, we have make sure there are no music teachers. So this function is going through, again, in the plain Java way, plain old Java way, of saying, okay, here's my teachers list. Are any of the teachers a music teacher? If they are a music teacher, then we'll return false. Otherwise, we'll return true. So let's look at the streams way of doing this, right? So again, we're going to go into teachers list dot stream, and then from there we'll just go ahead and use the terminal operator of none match. So here we have no intermediary. We're not mapping, or we're not changing it at all, or we're not filtering, right? So we're just going straight to the terminal operator. So this will return a Boolean value of true if no matches, otherwise false, and we'll return that, right? So none match, and what is the thing that we need here? So we basically need to do a none match on this. So we're taking in a teacher, and no teacher dot subject should be equal to music, right? So let's go ahead and we will first of all execute this old function and see what comes out of it. And we'll say true because there are no music teachers right in our data set. only computer science and English teachers. And then after we go ahead and comment this out, it is also going to be true, right? So, and again, we can just clean this up a little bit. Like I said, I like to do the none match like that. And this can also be refactored out to a method. And basically, let's look at so this can also be factored out to a method. So you have your get teacher predicate or whatever it is, right? IntelliJ kind of does it for you. But it's a good way of being able to kind of factor it out or make your code cleaner if you have a lot of predicates, or maybe some that are multi-line, right? One thing to note as you get into bigger, one thing to note is that with your predicate, you can actually do this. So you can put in these little brackets, and you can do like a return here. So this will help if you have maybe multi-line code that you need to execute, or you can pull it out to that method. So now, next. Return highest paid teacher, right? So with return highest paid teacher, this is a ton of code, right? So I basically implemented like a greedy algorithm here. I'm getting the first teacher, and then I'm just comparing all the teachers. And if the new teacher's salary is greater than that teacher, I say, okay, I'm going to keep that teacher. Tons of code happening here. To me, this is personally like illegible, and I'm sure there's better ways to do it, even in the Java 8 way. But this is what I came up with. So let's go with this. Let's execute this method, return highest paid teacher. And we can see that the highest paid teacher is paid $69,000. They're a computer science teacher. The name is Michael, right? So let's see what we can do with that. So I'm going to comment out this block of code, and let's do it the streams way. So all we have to do here is get the teachers list again, stream it, right? And then we can use another terminal operator called the max operator, and we'll just pass in the comparator comparing, and we'll just say teacher get salary. I like to make them static. So all of this code turned into this, and you know, a big people who are normally against streams would say that streams make things a lot more harder to read, but I think when streams are written properly, it really cuts out a lot of the extra noise that we're writing normally as developers and makes it pretty easy to read. So this is just really the one-liner, or three, right? Comparison or stream version of doing the same thing, and the same response is there, right? So you have an optional teacher, and teacher is Michael. Okay. Next is create a comma-separated teacher string. So here you might have some CSV export, something where you basically have to say, okay, this is the subject and this is their name, right? Simple use case. And I went through, created a string builder, and I'm appending on that string builder the subject, the first name, and then I'll delete the last extra comma, because this way it'll keep printing out a comma at the end, and then just return string builder to string. And that's a fine way to do it. But what is the stream method of doing this? So we're going to use some of the same stuff and some different stuff. The first thing that we're going to be doing, which is the same, is we're going to return teachers list.stream, right? And then we're going to introduce a new intermediate operator called map. So with map, we're going to pass in a teacher to map, and then we'll just say teacher.getSubject plus, I'll add a dash in there, plus teacher.getFirstName, right? And then we'll collect it with the collectors dot joining, and we'll throw a comma in there. Okay, and we'll make this multi-line, throw a comma in there, do a static import on that, and it should come out the same exact way, minus this extra little dash that I added. But if I didn't add that dash, the same exact method, right? Okay, cool. Now, the last one we'll be going into is grouping by subject. So, I have some different teachers. Some of their subjects are computer science, some of their subjects are English. And I want to basically get that into a hash map which has buckets of lists, right? So, the current way that we did it is we went through to the hash map. We created a hash map rather. We are iterating over the teacher's list that were passed in, get the teacher subject name. If that's null, create a new array list and shove that teacher in there. Otherwise, just add the teachers to that array list, right? And then return the group map. And that's what's coming out. We have English, the bucket of teachers, and then computer science in the bucket of teachers, right? So, again, tons of code here. Not that it's difficult to read, or not that it's hard to read, but there's a way that we can make this, I think, a little bit cleaner. So what we're going to do here is we're just going to do a teachers list dot stream, right? And we're going to again use that terminal operator of collect, and we'll just say collectors dot grouping by, and then here we'll just pass in teachers dot get subject. So what will happen is that we'll stream this teachers list, and then it'll make buckets of teachers by their subject. And we can go ahead and run the same method, and we'll have the exact same output here. Perfect. And that is much cleaner than that. So guys, that goes over all the examples that I had in terms of how we can transition something from a plain Java version into the streams version. If you guys have any questions that I can answer, please go ahead and leave a comment down below. And if you guys did find this video entertaining or helpful or useful in your software engineering journey, please go ahead and subscribe and like the video, and maybe share it with a friend or two when they ask you what streams are. Anyway guys, thanks so much for watching. Have a great day.